Okay, hi guys. So we'll be continuing on seeing more examples of diazotization of amines. Okay, so let's say we have this compound, we have CH3, and we react it with NaNO2 in presence of 2 moles of HCl. So what would we get? Okay, let's actually have step-by-step mechanism only. So we have NaNO2 plus HCl as the first step. We'll get something like NaCl plus HNO2. In the second step, we have HNO2 plus again HNO2 plus again we have HCl. We'll get something like this water molecule will remove itself and we'll get NO2 plus Cl minus and H water molecule. Okay, in the third step what we will have is we will have PHNHCS3, and again this NO2 plus Cl will be attacked by this lone pair of nitrogen atom to convert itself into H plus would be released by the nitrogen atom. I am not showing it. NO2 plus, okay, and we'll have CH3 also here. Okay. Oh, NO2 would not be no longer a plus, as it is getting lone pair from this nitrogen atom. This would be the result. Okay, let's see another example. So we have what actually happens after we have diazonium chloride or diazonium salt with us. So it actually, suppose we are providing any Cl minus into the reaction mixture. So what we will be getting is this NO2, this N2 gas would be released, okay, and we'll get a free radical on this benzene ring. Okay, so and then Cl minus would be actually attacking on this, or rather Cl dot would be attacking on this free radical to form Cl. Okay, the exact mechanism as to how the diazonium salt in presence of CuCl or KCl or Cl minus which I am saying in this case, the exact mechanism is not yet clear as to in the organic chemistry society as well, that exactly how this reaction happens, but we'll assume that Cl minus will come and get attached to this benzene ring. Okay, so we have Cl minus, we have Cl minus here, and what will happen is we'll get something like this as our product. Okay, I'm not showing any intermediary process because the mechanism is still not clear in the organic chemistry society. Okay, so let us actually now talk about replacement reaction. But I can actually give you a rough estimate as to how it would have happened. So let me first have this replacement reaction. So suppose we have just let me remake it. I'm not that good at drawing. We have something like this, and we have diazonium salt in it, and obviously we have ice cold water. Okay, we have a vessel, so this is with ice. Okay, so now what will happen is, suppose we have something like this in which I pass KCl, and in presence of or with CuCl we'll get something like this. Okay, so how does this happen? So basically CuCl actually would exist in, I'm just telling you the rough mechanism, the exact mechanism is still not clear in the in books. So Cu2Cl2 exists as a dimer form. Okay, so we can have CuCl as Cu free radical and Cl free radical. Okay, now what happens is we have this diazonium salt and Cl minus. Okay, now what will happen is this Cu dot will actually oxidize itself and become Cu plus a electron is released from the copper orbital. Okay, now what will happen is this nitrogen gas will get released from this mixture and will get, okay, I'll just show you the steps together only. So this Cu gas, this nitrogen gas will release itself, and this electron will get attached to this phenyl ring and will form a phenyl free radical. Okay, with the addition of N2 gas and Cl minus would be there in the mixture. Now what will happen is this Cl dot, which is also a free radical, will combine with the phenyl free radical to form chlorobenzene. Okay, so this is a rough mechanism which could have happened. Exact one is not clear. Okay, as to how this replacement reaction happens. Okay, I have just given you estimate this is the approximate mechanism via which the reaction could have happened. Okay, so now if we pass it in presence of CuBr, then we'll get PHBr. If we pass it in presence of PHCN, in presence of CuCN, we'll get PHCN. So all these are examples of Sandmer's reaction. Okay, now we have CuBr. Okay, so rather we have, let's say we have only, if we have CuBr, then Sandmer reaction will take place. Rather, if we have only copper and we have KBr, then actually Gattermann synthesis takes place, in which we get Br attached here. This is known as Gattermann synthesis. Okay, now if we have something like this, in which we pass H plus and BF4 minus, then obviously, oh, just write it here only, then we will get something like PHF. Okay, this is known as Schumann reaction. Okay, next if we have something like KSH minus, then we would have something like PHSH. Okay, if we have hot boiling water, then we will have phenol. Okay, and if we have S3PO2, then we would have something like a benzene. Now how does this reaction of diazonium salt with H3PO2 take place? What actually happens is we get something like this is the, I'll just draw the structure of S3PO2. We have OH here and H here. So what actually happens here is this H minus will go and get attached with the releasing N2 group and will get attached to the phenyl ring, making it a benzene. Okay, so we'll get something like this. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples on the diazotization of amines, and we'll be looking at some interesting cases in which Grignard can also react with CuCl and oxygen. Okay, so till then, good luck and goodbye.